In problem number 5.4.3, we're asked which of the following, A, B, C, or D, is the difference of two squares. So first of all, the difference, here's a difference, here's a difference, here's a difference. This is not a difference, this is a sum, so right away we can cross this one out. And then we want is two squares. Now here's a square, x squared, here's a square, 16, I can take the square root of each one. Okay, 16, I can take the square root. And how about this one? 16 and 4. I know the square roots of both of those. This one up here is going to give us a problem, though. The 9's okay, but the 2, can't take the square root of 2 and get a whole number. So let's cross that one out. So what we're going to conclude then are these two here, that these two here, B and C, are the differences of two squares. And in problem number 6, we are told that you start with a student starts with m to the 4th minus 16 and then factors it like this. m squared, and then the square roots of 16 are 4 and 4. Make 1 plus 1 minus, right? Because this is the difference of two squares. So we just unsquare the first, unsquare the second, make 1 plus 1 minus. But the student did not get full credit because we got another difference of two squares right here. So we can get m squared plus 4, and this factor over here factors again as the difference of two squares, right? We've got something squared minus something squared. So let's unsquare each. We'll get m and m, 2 and 2, make one of them plus 1 minus. And that is the complete factorization of m to the 4th minus 16. Now in problem 7, we're given this difference of two squares, s squared minus 81. And 81, we can square root that and get a whole number, right? 9, square root of 81 is 9. So we're going to write this as, now these are conjugates. What we're going to do is unsquare each, s and s, 9 and 9, and the pattern is 1's plus, 1's minus. And it doesn't matter, I made this plus and this minus. Could have made this minus and this plus. Multiplication, remember, is commutative. And now we can't go any further. This is not squared, and it's a sum. This is not squared, so we've got this one now completely factored. Now in this problem, again, we've got the difference of two squares. So I got x squared minus square root of 144, that's 12. If you don't know it now, you'll get to know it because we're going to do quite a few of these, and as we encounter them, you get to know what those squares are. So here's what we're going to have. Let's write our two parentheses, putting in, right, these are conjugates. Let's just say it again. These are conjugates, and conjugates differ in one sign. So binomials differ in one sign. So we're going to have an x and an x, a 12 and a 12, make 1 plus 1 minus. And there is the complete factorization of x squared minus 144. And you know what? We're on a roll here. Let's just keep on going. At first, I was just going to just do these, 3, 6, 7, and 9. But let's just keep going. Here's number 11. Number 11 is to factor completely a squared minus 8. Well, this is a square. This is not. So what we're going to do is, this is not going to factor as the difference of two squares. So why don't we just write this as prime? There's nothing common that we can factor out, so we'll call this prime. And we might as well just keep going. Here's number 13. Number 13 is r squared plus 49. And notice what we have here is we've got something squared plus something squared. This problem here is the sum of two squares. And there's no pattern for this. And don't think you're going to make one up. We're just not going to be able to do it. So we're going to call this prime. And we'll just keep on going again. So what we've got in number 17 is 81c squared minus 16. So it looks to me like we've got a difference of two squares, right? 9c squared and 4. So let's write this as our two sets of parentheses. And let's take a 9c, and then undo the 16. 4 and 4, make 1 plus 1 minus. And you can check this, you know. You can just multiply it out. There's 81c squared. And look at this outer product. Negative 36 36c, and then the inner product, positive 36c. Those are going to cancel. And then negative 16. And in number 23, I think that we have again the difference of two squares, right? 3w, 4p. So let's write our two parentheses, anticipating we can do this, and we're going to write as conjugate. So undo the squares. How about 3w, 3w? And for the 16p squared, how about 4p, 4p, make 1 plus 1 minus. And there is our complete factorization of that difference of two squares.